page 2 starts with number 13. So for number 13, again we have the same base, different exponents, so we know we can subtract the 1/5 minus 3/5. And 1/5 minus 3/5 is negative 2/5, that's 7 to the negative 2/5 power. And that essentially with a negative power will become 1 over 7 to the 2/5. Now if you put in 7 to the 2/5 to your calculator, you're going to get a decimal. So it is okay to just go ahead and leave your answer like this. You could also take the 5th root of 7 squared. Same thing, so this answer will be fine. For number 14 again, you notice that the 5th root of everything is being taken. So I'm just going to rewrite this so that it is the 5th root of everything inside. So that would be 81x to the 16th over 27x times 3x to the 10th. Now I am going to simplify the denominator. So that would again be the 5th root of 81x to the 16th over 81x to the 11th. So in this case, the 81's pretty much cross each other out. I'm going to use my laws of exponents to simplify x to the 16th over x to the 11th, so I subtract the exponents to get x to the 5th. And now the 5th root of x to the 5th is just x. So that's it. For number 15, to the negative 1/3 power, I know that I bring that up, so that just becomes 125 to the 1/3 power. And the 1/3 power is the same as taking the cube root. Cube root of 125 is 5. A couple of easy ones there. Another easy one, 8 half to the 4th is basically just 8 squared, and 8 squared is 64. For number 17, notice that they are both being raised to the negative 5/3 power, so you can just rewrite this as negative 2 times 4 to the negative 5/3 power. Negative 2 times 4 is negative 8, raised to the negative 5/3 power. And you can just basically say that's 1 over negative 8 to the 5/3 power. If you plug in negative 8 to the 5/3 power, that's actually negative 32. So your answer for number 17 is just negative 1 over 32. Again, you could get that by just plugging all of this into your calculator, but it's much easier to go ahead and simplify before doing that. For the next one, everything is being raised to the 6th power, so it's easier to rewrite this so that your radicals are in power form. That way you can distribute that 6. So 1/3 times 6 is 2, so that's 5 squared. 1/2 times 6 is 3, so that's 5 to the 3rd. And then you know that you can subtract those exponents to get negative 1. So that's actually 5 to the negative 1. And we know that that negative 1 puts it on the bottom, so you basically get 1/5. For number 19, you want to take the cube root of both of those, which is basically taking x to the 6th and y to the negative 6th and raising it to the 1/3 power. That's easier to simplify. When you do that, 6 times 1/3 is 2, so that's x squared. Again, 6 times 1/3 is 2, so that's negative 2. So since you have a negative 2 down here in the bottom, you know that's just going to come to the top. So your answer is just x squared, y squared. For number 20, you basically want to, on the inside, simplify first, which is basically taking all of that and raising 162 over 2 to the 1/4 power. Now that 2 is still there, so I'm then going to have to take that and raise that to the 2nd power. Now you can simplify the power to the power by just multiplying. So this essentially becomes 162 over 2 is 81. Half times a quarter is, or 2 times a quarter is a half. So this is just basically the square root of 81, which is 9. For the last one, you're taking the 4th root of everything inside. So that's 3m squared times 9m to the 7th times 3d cubed. And now you're going to combine like terms. 3 times 9 times 3. Oops. 3 times 9 times 3 is 81. So therefore this is basically just the 4th root of 81 combine your m's, so that's m to the 9th, 2 plus 7, and then d cubed. You could now take the 4th root of 81, which is essentially just 3, and then you could leave the 4th root of m to the 9th d cubed, or you could rewrite them using fractions. If you did rewrite them using fractions, it would be m to the 9/4 and d to the 3/4. And that would be your answer. Alright, let's move on to our equations. Again, we want to solve the equations for x, and then we want to simplify if possible, and then we also want to check. So there are 3 things that we have to do for each of these problems. We have to solve, simplify, and check. Okay? So for the first problem, since I am taking, this is to the 6th power, the opposite of the 6th power is taking the 6th root, so I'm going to take the 6th root of everything. So the 6th root and the 6 here to the 6th power cross out, I'm just left with 2x minus 10, and then I'm going to find the 6th root of 64. 6th root of 64, remember I can either have the plus, the positive, or the negative version of that, so that's plus or minus 2. I'm going to add 10 to both sides. I'm going to be left with 2x equals plus or minus 2 plus 10, and now I'm going to divide both sides by 2. So that's x equals, first answer, 2 plus 10 is 12, 12 divided by 2 is 6. Negative 2 plus 10 is 8, 8 divided by 2 is 4. So I have 2 possible answers of 6 and 4. Okay. If I want to check those solutions, I can go back, plug them into the equation for 2 times 6. Minus 10 to the 6th power equals 64. They do both check out, I'll tell you that. But you would need to show that work to check. Show. Please show it. For number 23, to solve this equation, you want to first divide by 2, because notice the 2 is not inside the parentheses, so I need to get rid of it first. So that would be x minus 1 cubed equals 125. Now, since I'm raising it to the 3rd power, I want to take the cube root of both sides. So the cube root of something cubed is just going to be x minus 1. Cube root of 125 is 5. Add 1, x equals 6. Now notice for this one, when I took the cube root of 125, I did not get a plus or minus 5. That is because this is an odd root. If it were an even root, like over here, 6 was an even root, that's when I had the plus or minus. But since this is an odd root, I do not get the plus or minus, it's just 5. So you could go through and check this solution. If you checked it, it would be 2 times 6 minus 1 cubed, question mark, is that equal to 250? 6 minus 1 is 5, so 2 times 5 cubed, is that equal to 250? 2 times 125, is that equal to 250? Yes, it is. 2 times 125 is 250, so 250 equals 250, and that is correct. Again, for number 22, both 6 and 4 do check out. There are no extraneous solutions. We talked about extraneous solutions in class today. For number 24, notice the 4th power is just with the x, so I can go ahead and just get rid of the 2 first, so that gives me 3x to the 4th equals 3. Divide both sides by 3. X to the 4th equals 1. Take the 4th root of both sides. And again, this is an even power, so that means I either get plus or minus 1. You could go through and plug those in and check them. You would have to do 3 times 1 to the 4th plus 2, is that equal to 5? And you would have to do 3 times negative 1 raised to the 4th power plus 2, is that equal to 5? And they both are true. Both of them do check out, but you would need to show that simplification process like we did in number 23. For number 25, notice the 5th power is over here. The 50 is not included, so I want to do the opposite of adding 50 and subtract 50. 50 over here cancel. I'm left with 2x minus 1 raised to the 5th power equals negative 32. Now, since the 5th power is on here, I want to take the 5th root of both sides. 5th root of a 5th power is just 2x minus 1. 5th root of negative 32 is negative 2. Again, notice I do not get the plus or minus, I just get the one answer that I get when I put in my calculator, and that's because it is an odd power. Now I want to add 1 to both sides. That gives me 2x equals negative 1. Divide both sides by 2, and x equals negative 1/2. Again, leaving your answers in fractions is the best way to go. Then you could go through and plug that negative half back in, which you do need to show, because remember, we did have to check it, and so show the work to check. All right, this was page 2, and there is one more video for page 3.